जय हिंद दोस्तों एंड वेलकम बैक टू माय चैनल। BARC भाभा एटॉमिक रिसर्च सेंटर की बहुत सारी रिक्रूटमेंट्स अभी आ रही हैं, जैसे कि OCS प्रोग्राम, DGFS प्रोग्राम दैट इज साइंटिफिक ऑफिसर पोस्ट, और the next is stipended trainee category 1 and category 2. So there are many departmental exams also conducted by BARC under the Department of Atomic Energy, Government of India. So टॉपिक्स वाइज कुछ कुछ कंसेप्ट हम पढ़ेंगे, जैसे कि एग्जाम पास आ रही है तो कुछ कुछ इंपॉर्टेंट टॉपिक्स को हम देखेंगे। द वेरी फर्स्ट टॉपिक आई विल बी टॉकिंग अबाउट इज द न्यूक्लियर केमिस्ट्री। दिस इज द पार्ट 1 वीडियो ऑफ द सीरीज। दिस इज विल बी अ फुल सीरीज of near about 30 to 40 lectures. So let's begin. So the very first thing we should know before reading the nuclear chemistry is the what is an atom. Everything is surrounded by these things. Atom. What is an atom? What is atom all about? We all are atoms. We all are composed of atoms. Everything around us is composed of atoms. Everything we wear, everything we eat, anything we eat, anything we wear, anywhere we are going, everything constituted of an atom. So what is an atom? Atom is just given by John Dalton, is all matter was composed of small particles called atoms. This is a very small particle. It seems big, but it's a very small atom, small particle. And he visualized the atom as hard solid individual particles, incapable of subdivision, incapable of subdivision. So, and there are some fundamental particles related to atom. Those are the proton, neutrons and the electrons. We will read about all these things, how the things evolved and what is the timeline. So here is the timeline that John Dalton gave in 1805. Now after that, it was the J.J. Thomson who gave the positive and negative charges. What are the positive and negative charges? After that, the Rutherford, the nucleus, 1909. Rutherford, the nucleus model was given by Rutherford. Then the Bohr atomic model for the energy levels. What are the levels of the energy? And lastly, the Schrodinger in 1926 electron cloud model. Means electron. There is electron cloud everywhere. This is not stationary. The electrons are not stationary. Not stationary. They are rather mobile. They are having clouds. The density of electron is defined in terms of the electron cloud. So let's proceed to the first very thing, that is the cathode rays, the discovery of the electron, how the electron was discovered. And this model was given by J.J. Thomson in 1896, and this figure is regarding the production of cathode rays. कैथोड रेज कैसे प्रोड्यूस हुई थी? व्हाट आर कैथोड रेज? तो देखिए, द नॉलेज ऑफ द इलेक्ट्रॉन वाज गिवन बाय J.J. Thomson through an electric discharge model or the discharge tube. This is the discharge tube. Now is discharge tube में they have having glass tube with metal electrodes. These are the metal electrodes. These are the metal electrodes fused in the walls पे fused हो गए हैं. Through a glass slide arm there is some vacuum. There is some vacuum to get the gas out. गैस जैसे बाहर निकल सकती हैं, and they are connected through a high voltage near about 10,000 volt. I'm repeating, this is about 10,000 volt, and the air is partially evacuated. Now the electric discharges passes between the electrodes and the residual gas in the tube begins to glow. Now if virtually all the gases is evacuated within the tube, the gas is replaced by a luminous or faintly luminous rays. I am saying out the rays. These are the rays. These are the rays. They are moving. This is the cathode, that is the negative electrode. This is the anode, this is the positive electrode, and these rays are known as the cathode rays, and they produce fluorescence. Means they give a bright light in the screen. Here is the screen. They are giving bright light, that is the fluorescent at the end of the cathode. So the rays which proceeds from the cathode and move away at right angles to it in straight lines are called the cathode rays. These are the cathode rays. Now, some of the properties of the cathode rays, if I will talk, they travel in straight lines away from the cathode, as I told. They produce fluorescence. Fluorescence, a glow. This is just a glow, sparkling glow. When they strike the glass wall of the discharge tube, the cathode rays produce X-rays when they strike a metallic target. Cathode rays are deflected by the electric as well as the magnetic field in the way indicating that they are streams of minute particles carrying negative charge. So what are the cathodes? These are the negative charges. These are the negative charges. Now, after this, by counterbalancing the effect of the magnetic and electric field on cathode rays, J.J. Thomson was able to work out the ratio of the charge and mass ratio. This is the very important concept. E by m of the cathode particles. In SI unit, the value of E by m of cathode particle is minus 1.76 into 10 to the power. This is not 18 to the power 8. This is 18 to the power 8, not 10, 188. 18 to the power 8 coulomb per gram. We are getting the how the particle, how the sorry. This is 10 to the power 10 to the power 8 minus 1.76 into 10 to the power 8 coulomb per gram. So this is all about how the things works. As a result of the several experiments, Thomson showed that the value of E by m of the cathode particles were the same of regardless of both the gas and the metal of which the cathode was made. So this is all about the thing. Now, this proved that the particles making up the cathode rays were all identical and were constituent part of the various atoms, and these were called as the electrons. These were called the electrons. Now, next is the measurement of the E by m for electrons. How the E by m, the charge by mass ratio for the electrons, or the absolute or the ratio of the charge to mass of an electrode was measured by an apparatus or a device given in this figure. So this is the measurement of the E by m for the electrons. Like this is the cathode, this is the perforated anode. Perforated anode means there is a hole in the anode electrode, and the cathode rays are moving through a narrow slit. This is a very narrow slit. This is the evacuated glass tube, and this is the beam of electrons, and they are moving in a circular path. They are moving in a, and the electrons are deflected. These electrons are deflected in a circular path, while the spot, and we are getting a spot in the fluorescent screen as X. Now, as they are moving in circular path, the spot is shifted to Y. This spot is shifted to Y. The radius of the circular path, the circular path we are getting, or this circular path we are getting, the circular path can be obtained from the dimensions of the apparatus. First is the dimension. What is the dimension of the apparatus? Second, the current. So the radius, this is very important concept. The radius of the circular path. If you are talking about the circular path, the radius of the circular path, this is also circular, this is semicircular type of, this is semicircular type of. So the circular path, and this is the electromagnet, this is electromagnet, and how it is deflecting. The electrons are deflected in presence of what? Electric and magnetic field, and both magnetic fields. So the radius of the circular path depends on the, one is the dimension. What is the dimension of my apparatus I am taking? Dimension of apparatus, this is very well known. And the current, how much current is passing. Third is the number of turns of the coil of the electromagnet. My electromagnet is having coils, so number of turns of the coil. And the angle of deflection, angle of deflection, by what angle it is deflecting of the spot. So by what angle this is deflecting. So this is all about the radius of the circular path I can find out. So an electrostatic field of known strength is then applied to bring it back to the original position, that is X. So then from the strength of the electrostatic field and magnetic field, it is possible to calculate the velocity of the electron. So we can calculate the velocity of the electron. How we can calculate the velocity of the electron? Now look at these things. Let me show you. Now we can equate the magnetic force. this electron, the electron beam of electrons, they are moving through a force, so the equating the magnetic force on the electron beam to the centrifugal force. So what is the magnetic force? This is BeV is equal to the centrifugal force, that is the mv square by r, where B is the magnetic field strength, magnetic field strength, and V is the velocity of electron, velocity of the electron, E is the charge, charge of electron, M is the mass of electron, मास ऑफ इलेक्ट्रॉन है, r क्या है हमारा, r is the radius of the circular path, radius of circular path of electron in magnetic field. So this is all the things. तो यहाँ से हम E का वैल्यू या फिर E by M का वैल्यू निकाल सकते हैं, that is equal to V by BR, isn't it? This is the one equation I am getting. Now the value of R we can be obtained from the dimensions of the tube and the displacement of electron spot on the fluorescent skin. Now, when the electrostatic field strength and the magnetic field strength are counterbalanced, तो क्या होगा? My BEB will be equal to the EE electrostatic. So my V is equal to E by B. Now putting this equation over here, so E by M is equal to E by V square R. This is the final equation I am getting for E by M, charge by mass ratio. And after putting the values of all the variables, I am getting the E by M is equal to minus 1.76 into 10 to the power 8 coulomb per gram. This is the value I was talking about here. See, minus 1.76 in 10 to the power 8 coulomb per gram. So this is the thing. Now moving on to the, when we knew about the E by M ratio, we are now calculating the determination of the charge of an electron. How can we calculate the charge of an electron? So this is given by an experiment that is called the Millikan oil experiment. Millikan oil droplet experiment given by a scientist, a chemist, that is Millikan. So the apparatus is shown over here. This is the original apparatus, and how it is working. These are the oil droplets. This is the spray gun. Electrons or oil are sprayed. Oil particles are floating over here. These are the two electrodes. They are perforated electrode. There is a hole. So this is the positive terminal. This is the negative terminal. Okay, so this is the perforated electrode, and through this hole these electrons are going downwards to this plate, these are the chargeable plates, and here I am applying the X-ray to see, and through a telescope I am seeing the whole phenomena, how it is going, and the upward force, and after some time we have observed that the upward force due to the negative charge on the drop, there is a charge on the negative drop, which drop, oil drop, is equal to the weight, that is the mg. This ऊपर का जो force लग रहा है, ऊपर जो force है, that is equal to the weight downwards, weight of the drop. So as the X-ray struck the oil molecule, this oil molecule, this is striking, the electrons are produced. The drop captures one or more electrons and get a negative charge. So my charge is equal to Q is equal to N into E, where N is the number of electrons and E is the electronic charge, that is minus 1.6 into 10 to the minus 19 coulomb. This is all the thing. After this, how can I calculate the mass of an electron? If I would be asked what is the mass of an electron, how can I calculate? So by using the two variables, the values, that is the E by M, we know that is minus 1.76 into 10 to the power 8 coulomb per gram. It is given by Thomson. And the E, that is minus 1.6 into 10 to the power minus 19 coulomb, that is given by Millikan. Now E divided by E by M is equal to minus 1.6 into 10 to the power minus 19 coulomb divided by minus 1.76 into 10 to the power 8 coulomb per gram. Now my M is getting 9.1 into 10 to the power minus 28 gram or equal to 9.1 into 10 to the power minus 31 kg. So this is the mass of an electron. Now if I would calculate the mass of an mass of an electron. If I'm interested in calculating the mass of an electron with respect to the with relative to the mass of hydrogen or mass of electron, mass of an electron relative to hydrogen, relative to hydrogen. This is the relative mass I am calculating. So as we know, here we know we have to put the values of the Avogadro numbers. Avogadro number is what? The number of atoms in 1 gram atom of any element. Avogadro number, that is the Na. This is 6.02 into 10 to the power 23. Now what is this? This is the number of atoms. Number of atoms in 1 gram atom of any element. Of any element. Isn't it? So how can I calculate from there? So we know the mass of 6.02 into 10 to the power 23 atoms of hydrogen is equal to what? 1.008 gram, isn't it? Now the mass of a hydrogen atom is equal to how much? 1.008 divided by 6.02 into 10 to the power 23 gram. That is equal to 1.67 into 10 to the power minus 24 gram. This is the value I am getting. But mass of an electron is what? Electron is equal to 9.1 9.1 into 10 to the power minus 28 gram. So the mass of hydrogen divided by mass of electron is how much? 1.67 into 10 to the power minus 24 gram divided by 9.1 into 10 to the power minus 28 gram. That is I am getting as near about 1.83 into 10 to the power 3 is equal to 1.835. This is equal to 1835. So what I am getting from here? My mass of hydrogen, the mass of hydrogen is equal to 1835 times mass of electron, isn't it? Or the vice versa, mass of electron is 1 by 18835 times of mass of hydrogen. So are you getting? The mass of electron is 1 by 1835 time of the mass of the hydrogen atom. This is the crux of the things. Now moving on to the different things, we got that the electron is the substance or the subatomic particle which bears a charge of minus 1.6 into 10 to the power minus 19 coulomb and has mass is equal to 9.1 into 10 to the minus 28 gram, isn't it? So what about the positive rays? What are the positive rays? So the positive rays, it was given by the Goldstein. Goldstein, there is a chemist, Goldstein. There was a, sorry. The Goldstein gave a used a discharge tube. He also used this discharge tube with a hole in the cathode. There is a perforated. This is the perforated cathode. There is a hole. This is the anode. That is the positive terminal. This is the cathode. That is the negative terminal. The two electrodes are over here. Okay. So he observed that while cathode rays were streaming away from the cathode, as we have seen here, you can see that the cathode rays they travel in straight lines away from the cathode. So they are moving away from the these cathode rays were streaming away from the cathode. There were colored x-rays or colored rays which produced simultaneously when passed through the perforated cathode and caused a glow on the wall. There is a glow on the wall opposite to the anode. This is the anode, this is my glow I am getting in the opposite wall, and these are the positive ions, positive rays which are going, these are the negatives moving here. Unlike charges attract each other, so these positive rays, these are the positive rays plus, these are the positive rays. So Thomson studied these rays and showed that they consisted of particles carrying a positive charge. These are called as the positive rays. On the fluorescent screen I am getting these as positive rays. Now, some of the properties of the positive rays. Some of the students might find it boring, but this is very much important to know about the subatomic particles, because in nuclear chemistry you will get to know about all these things, like what are the subatomic particles, what are the electron, proton, neutron, their relations, what is the mass relation, what is the charge relation, everything. So just be with me, stay tuned with me. So some of the properties in the positive rays are they travel in a straight line in a direction opposite to the cathode. True. They are deflected by electric as well as the magnetic field in such a way that indicating they are positively charged. True. The charge to mass ratio E by m of the positive ray particles varies with the nature of the gas. Nature of the gas displaced in or placed in the discharge tube of the positive particles I'm saying. They possess mass many times the mass of an electron. They cause fluorescence in zinc sulfide, ZNS. This is the screen, zinc sulfide screen. They produce fluorescence or glow. They used to glow. Now, can you say how these positive rays are produced? How positive rays are produced? Can you say how the positive rays are produced? See, I have a metal. They're collided by the electron. So the after the when a high-speed electron or the cathode rays strike a molecule of a gas placed in the discharge tube, they knock out the electrons from it. So they knock out the electrons, and it gives me the positive ion and the electrons. Are you getting? This is the how the positive ions are created. These positive ions pass through the perforated cathode. See here the perforated cathode they used to travel and appear as positive rays. So this is the whole thing. And when this electric discharge is passed through the gas under high electric pressure, its molecules are dissociated into atoms, and the positive atoms constitute the positive rays. These are the positive rays which are constituted by the positive atoms. So, moving on to the protons. Protons, Goldstein discovered protons in the discharge tube containing hydrogen. Same. See, my hydrogen, it is giving H plus electron, giving the electron or emitting the electron. This is the positive particle, that is the proton H plus. So, what is the proton? Proton, the actual mass of a proton is equal to 1.67 into 10 to the power minus 24 gram. We know. So the proton has a, but on a relative scale, proton has mass of 1 AMU. Relative scale 1 AMU. This is AMU is atomic mass unit. And the charge of proton is equal to the magnitude but opposite to that of an electron. That is 1.6 into 10 to the power minus 19 coulomb or plus 1 elementary charge. So these are all about the protons. Now the neutrons. What are the neutrons? In 1932, James Chadwick discovered the third subatomic particle. He directed a stream of alpha particles. These are the alpha particles, 2He4. Sorry, 2He4. Atomic number 2, mass number is 4. 2He4 helium atom. They collided a beryllium target. This is the beryllium target, and they found that a new particle was ejected. These new particles was neutrons. These neutrons, and it has almost the same mass as that of proton, but has no charge. So the mass is near about 1.67 into 10 to the power minus 24 gram, but charge is equal to, if Q I am saying it is 0, the charge is 0. The charge in detector indicates there was a charge detector, so it was showing as 0. So the neutron is a subatomic particle which has a mass almost equal to that of a proton and has no charge. So these are all about the subatomic particles. So as a summary, to sum up all the things, we know the electrons, it is the in AMU, it is 1 by 835 times of hydrogen, and protons and neutron, it is 1 AMU. In grams, it is 9.1 into 10 to the minus 28 gram, and proton mass is 1.67 10 to the minus 24. Neutron is also same. The charge, this is negative. Electrons, positive, protons are positive charge. Neutron is neutral, no charge. This is the in Coulomb scale, minus 1.6 into 1.6, and it is 0. So these are all the notations, and electron E minus, P plus, N or N0. So this is all for today. This is the total basics of the nuclear chemistry. This is the starting of the nuclear chemistry in the very part 1 of the video lecture. In the subsequent videos, we will discuss about the nuclear chemistry in depth of all the things and how it is working, what are the nuclear fission, fusion, radioactivity, the law displacement, the displacement loss, displacement series, the everything we will be covering. But stay tuned with me, and please give support and love to the channel. Thank you for watching.